For this basic circuit lab, you'll be investigating how does the voltage that you apply to a resistor, there's the resistor, actually increase the current that flows through it. So here's a basic circuit diagram, very basic idea. You're going to have a power source on one end, current will flow out, will flow through the ammeter. It actually doesn't matter where the ammeter is in the circuit as long as it's in series, will flow through your resistor and then back. And so you're going to change your voltage that you're applying to the circuit, and thus all of it's going to drop across the resistor because there's only one there. And you're going to measure the current using the ammeter. So here's how the circuit looks in reality here. You're going to have a power supply. You'll hook the power supply up on the DC side, direct current side. Use the alligator clamp wires and the banana side to actually plug in to it. You'll notice that the power supply ranges from 1.5 to 12 volts in those increments. So those are going to end up being your independent variables. 1.5, 3, 4.5, 6, 9, and 12 can be your independent variables. You'll be given a circuit kit. Now, you don't have to use a circuit kit like this. Instead, you could just use wires, but I chose to use these circuit kits because it tries to make it look a little bit more like the circuit diagrams you're going to end up using. So basically here, this is part of the circuit, right? Where here is my power supply. Just the power supply is over here connected by wires, quite obviously. Maybe we should draw those wires coming out like this, right? And then my power supply is over here and then coming back over. This is just here to support all of this since I have it leaned up so this side doesn't fall down. And here's my ammeter. Now, my ammeter is actually a multimeter, all right? So my ammeter here, and then my resistor. Now the ammeter hooked up where you have plugs coming in. I used alligator clamp wires to go in and out. Now for the ammeter, let's talk about that for a second here. The ammeter actually has, have to plug that back in, a few different settings. It can do direct current down here on bottom, alternating current. It can do direct current voltage, alternating voltage, resistance, and if you'll get up right, the temperature. Now, if I unplug these little guys, there's a spot where you're going to plug in the black one. It actually doesn't matter the color, but it's just easy to help. The black one always goes in there. And then what you'll notice is there's two other red holes. We're not going to use the temperature or the ohm or the volt on this side. Whenever you're trying to measure voltage or resistance, you would end up plugging it in on that side. It's labeled, might be a little small. On the left-hand side in yellow is where you end up having current. There's a 20 amp spot. If you're actually using a large amount of current, we'll never end up using that in our classroom. And then there's a spot for micro and milliamps. Make sure to plug it into the micro milliamp hole. Now let's get that re-plugged up here since I lost that wire. And the lab's very simple. Go ahead and turn on your multimeter to the 20 milliamp spot. Always start with the largest one on the largest possible setting on a multimeter, and then gradually turn it down. If you start too low and your current is above that, you might blow a fuse. Get everything hooked up. Notice the circuit, right? I have a resistor, wire, power source coming all the way around through the ammeter. The ammeter is wired in series, meaning there's an actual break in the circuit. The current has no choice but to go through the ammeter before it goes through the resistor. There is no possible divide. So it's one big loop is the idea. Turn on your power supply, maybe starting at the 1.5 volt here. And then you'll end up getting a current reading. I'm on milliamps right now. So I'm reading somewhere around 11.5, 11.4, somewhere in there, milliamps. There will be some variability. Hello, now you're trying to figure out your uncertainty there. Wait for a minute, it might stabilize. And then you turn it up, you get a new reading, turn it up, get a new reading, so forth and so on.